Hello, my name is Eric Clausen, and I'm the author of the topographic map mystery, Geology's Unrecognized Paradigm Problem. And in that book, I discuss a problem that the geologists have, and that is that their accepted uh, paradigm, uh, which explains the geology and glacial history of North America, does not explain most of the United States Geological Survey topographic map, drainage system, and erosional landform evidence. And in this paper or presentation, I'm going to be discussing an area in southeast Pennsylvania known as the Chester Valley. This is not discussed in my book, but it's an area that illustrates the problem that my book does discuss. And the Chester Valley is in southeast Pennsylvania. This is a map of southeast Pennsylvania, and it's showing the various physiographic subdivisions in the Piedmont province in southeast Pennsylvania. And the Chester Valley is this narrow lowland that we see here. Philadelphia would be right here. This is the Delaware River flowing in a south direction along the Pennsylvania-New Jersey border, and the Susquehanna River flows in a south direction here. And you note that the Chester Valley extends between those two rivers, but it doesn't go all the way to the Susquehanna River, nor does it go all the way to the Delaware River. So it's kind of an odd feature there, and we'll look at it and discuss what is I see as a major drainage history problem in the Chester Valley. Now, the Chester Valley is definitely not an obvious river or stream valley, and many geologists see no evidence that a river or stream ever flowed through it. And it's crossed by at least 7 independent south-oriented drainage routes, and also by the drainage divides between those drainage routes. And those drainage divides include the divides between the Delaware and the Susquehanna rivers, and also the drainage divide between the Schuylkill River and the Delaware River. Now, the drainage history problem that I'm going to be discussing is how could the 7 different drainage routes and their drainage divides develop across the Chester Valley if the Chester Valley had already been in existence when those drainage routes were formed? Or if the Chester Valley had been formed first, how could or if the drainage routes had developed first, how could the Chester Valley have been eroded? And to begin exploring this drainage history problem, I'm going to show you a group of slides starting in the west and proceeding eastward as we look at each of the drainage routes and also at some of the major drainage divides where they cross the Chester Valley. But before doing so, I want to discuss very briefly a hypothesis that some geologists have proposed as a Chester Valley origin, and that is that the Chester Valley floor is composed of carbonate rocks, while the rocks on either side of the Chester Valley are other types of rocks, generally metamorphic or sedimentary rocks. And there are some sinkholes and other karst features present on the Chester Valley floor, although we will see that surface drainage is present throughout most of the Chester Valley floor regions. It is possible, at least that the drainage routes developed independent of the Chester Valley, and that after the drainage routes had been formed, that solution processes, in other words, the carbonate rocks were dissolved slowly, and those solution processes gradually lowered the Chester Valley floor around the pre-existing drainage routes or the pre-existing valleys. If so, the Chester Valley floor should probably have high drainage divides between the various south-oriented drainage routes that cross it. Now, the presence of high drainage divides between the south-oriented drainage routes would support the hypothesis, and the lack of high drainage divides between those south-oriented drainage routes will suggest an alternate hypothesis is needed. So let's look at the Chester Valley proceeding from the west end, going to the eastward, and let's look and see whether we have high drainage divides between the south-oriented drainage routes that cross it. Now, this is near the west end of the Chester Valley. This is the town of Quarryville in Pennsylvania. And here we're seeing Bowery Run. It's a tributary to another tributary that flows to the Susquehanna River. So we're in the Susquehanna River drainage basin. This is the Chester Valley western end here. You can see it's a lowland with ridges on either side. And Bowery Run crosses the Chester Valley. And it looks as though Bowery Run doesn't even know that the Chester Valley is there. And note that on the map that we can see surface drainage routes draining parts of the Chester Valley floor. So we're not seeing a lot of evidence for karst features here. Now, as we continue eastward, we get to the area south of Christiana, Pennsylvania, and we have another Susquehanna River tributary coming down through a deep water gap, crosses the Chester Valley as though the Chester Valley wasn't even there, and then it cuts another deep water gap as it continues further to the south. And here again, we're seeing surface drainage on the Chester Valley floor. We're not seeing a lot of evidence of karst type features such as sinkholes. And if we continue eastward from there, we come to Parksburg, and at Parksburg, there's a very major drainage divide. The dashed red line here shows the drainage divide between the Delaware River and the Susquehanna River. The drainage divide crosses the Chester Valley and there's no significant high point on the Chester Valley floor between the two different drainage basins. And so and again, notice that there's surface drainage over much of the Chester Valley floor. So that we are not seeing a high drainage divide there. And this is a very significant drainage divide in much of Pennsylvania. Now, as we continue east from Parksburg and the drainage divide between the Susquehanna and the Delaware rivers is right here, we come to Buck Run, and now we're looking at drainage in the Delaware River drainage basin. Buck Run flows to Brandywine Creek, and we're going to see more Brandywine Creek head tributaries as we proceed eastward. And Buck Run crosses the Chester Valley, again, almost ignoring the fact that the Chester Valley is there. And again, I want to emphasize the surface drainage that you can see on the Chester Valley floor. And we're not seeing sinkholes or other types of karst features that we would expect if the Chester Valley floor had been lowered by karst processes. Now, as we continue eastward, we come to the town of Coatesville, where the west branch of the Brandywine Creek flows south across the Chester Valley, again, almost completely ignoring the fact that the Chester Valley is there. And again, if we look closely, we can see evidence of surface drainage, although we can see some evidence of maybe ponds here and there, which may or may not be related to karst features. So that we definitely are seeing a major drainage route across the Chester Valley. And then if we continue east, And there is no real significant high drainage divide between the west branch of Brandywine Creek and the east branch of Brandywine Creek that here at Downingtown. And again, the east branch of Brandywine Creek crosses the Chester Valley also almost without paying any respect to the fact that the Chester Valley is there. And again, I want to emphasize that there is surface drainage over most of this area, although it's possible that we're seeing some of these ponds and lakes may be related to karst features. They certainly, and we've definitely got a major quarry here, which may be mining some of the carbonate rocks. Now here, if we continue east from Downingtown, we come to another major drainage divide. This is the drainage divide between the Delaware River drainage basin and the Schuylkill River drainage basin. And the dashed red line here is showing you the drainage divide location. And I want to call your attention to two different streams. They start out here on the south wall of the Chester Valley, and they flow north. This one is Valley Creek East. This one is Valley Creek West. They flow down the slope on opposite sides of the drainage divide. They're separated by maybe less than a third of a mile. And once they get on the Chester Valley floor, they turn and flow in opposite directions. And if we look closely at the Chester Valley floor, we can see that there's actually a valley that links these the east and the west oriented valleys, suggesting that water once flowed across here. And again, I want to emphasize the presence of surface drainage across the Chester Valley floor here. Now, if we continue east from there, this imagery is showing you a larger area. We're looking at the Schuylkill River here, which is the first of the drainage routes, which appears to be perhaps influenced by the Chester Valley presence because it flows in a east-northeast direction here along what might be the Chester Valley north wall. Then it comes diagonally across the Chester Valley, then it cuts south, and then it flows east-northeast direction along what might be considered the Chester Valley south wall before it turns in a southeast direction to flow down into Philadelphia. Now, so the Schuylkill River, it's without question the largest of the drainage routes that crosses the Chester Valley. It does appear to have been somewhat influenced by the Chester Valley presence, but it, like the other drainage routes, it cuts completely across the Chester Valley. Now, if we continue east from the Schuylkill River, the last drainage route that flows south, and I'm showing an older topographic map here without all the cultural features that have been added since as the city of Philadelphia has sprawled, is we see Wissahickon Creek flowing across the Chester Valley here. And Wissahickon Creek flows in a south direction here across the Chester Valley, and then it enters a deep gorge on its way to the Schuylkill River, even though the Chester Valley extends in a west-southwest direction here with no high drainage divide and no separating it from the Schuylkill River. So this poses a puzzle here, how why Wissahickon Creek would enter this deep gorge here and cut a gorge which is almost 7 miles long across a very resistant upland bedrock region. Now, we didn't see any high drainage divides between the various drainage routes leading that were crossing the Chester Valley. So probably the first hypothesis is not correct. In other words, it's very difficult to explain the Chester Valley as having been eroded after the drainage routes had eroded their valleys across the Chester Valley. Now, a second hypothesis, and this is one that has not really been considered by the geological community, is that the Chester Valley was eroded at the same time that headward erosion of the various drainage route valleys was occurring, and that this was during massive southwest-oriented, probably continental ice sheet meltwater floods. Now, the geologic literature does not usually describe massive southwest-oriented continental ice sheet meltwater floods flowing across southeast Pennsylvania. If the floods were large enough, though, and lasted for prolonged periods of time, it is possible that southeast Pennsylvania drainage systems could have evolved as deep valleys eroded headward across the southwest-oriented floodwaters in a progressive sequence from the southwest to the northeast. And in this sequence, as each valley eroded headward in a north direction, it would have captured the southwest-oriented floodwaters and diverted the floodwaters more directly toward the Atlantic Ocean. Now, as I said, the geologic literature does not describe such large floods flowing across southeast Pennsylvania. However, it's not unreasonable to assume that such large southwest-oriented floods could have flowed across southeast Pennsylvania because the continental ice sheet margin is recognized to have been only a short distance to the north. And if those floods did flow across southeast Pennsylvania, the Chester Valley bedrock, because it's easier to erode than the bedrock on either side of it, could have been lowered at the same time that the deep south-oriented valleys were being cut across it in a progression from the west to the east. So let's look at a little evidence and see if the Chester Valley evidence maybe supports this. Now, looking at Valley Creek East, if you remember, this started at the Delaware River, Schuylkill River drainage divide, and then Valley Creek East turned in an east direction to flow on the Chester Valley floor. And this is Valley Creek East flowing on the Chester Valley floor. And as it gets close to the Schuylkill River, which is flowing in a southeast and then south and then east-northeast direction here, Valley Creek East, instead of continuing on the Chester Valley floor to the Schuylkill River, turns in a north direction to cut a deep water gap across what is the north wall of the Chester Valley here, and it joins the Schuylkill River as a barbed tributary at the point where the Schuylkill River turns from flowing in a south direction to flow in an east-northeast direction. And this is kind of an odd feature, and this is in the Valley Forge area of southeast Pennsylvania, the valley. This is where the national park is. And note again the surface drainage on the Chester Valley floor. Now, to understand why there might be a deep water gap here, rather than having Valley Creek East flow more through the Chester Valley, on the Chester Valley floor to the Schuylkill River, we maybe should think if there were major southwest-oriented floods before these south-oriented drainage routes had developed, it's possible that south-oriented water flowed perhaps from this Schuylkill River tributary that you see coming in here in a south direction into the Chester Valley region to join southwest-oriented floodwaters that were already flowing in a southwest direction here towards the Brandywine Creek valleys, which had probably been already cut across the Chester Valley at that time. And the southwest-oriented water was lowering the Chester Valley floor. So that the water gap would have been cut initially by south-oriented water before there was a deep Schuylkill River Valley here to stop the water from flowing in that direction. Now, here is the drainage divide again between the Schuylkill River drainage basin and the Delaware River drainage basin. And I showed you the valley that crosses, that extends between Valley Creek East and Valley Creek West. So with this, if the southwest-oriented water continued through the Chester Valley and it was eroding the Chester Valley down, what would have created the drainage divide would have been headward erosion of the Schuylkill River Valley across the Chester Valley. And then as the Schuylkill River Valley eroded headward, it would have beheaded the south-oriented water that was flowing south into the Chester Valley. And that process would have reversed the drainage. And if the Schuylkill River Valley was deep enough, the drainage reversal would have created the drainage divide that we see here, and it would have also reversed the drainage in what is now the Valley Creek East drainage basin. So that makes sense with the evidence that we're seeing. Now, if we come down here to Downingtown and we look at the what Valley Creek West does, Valley Creek West today does not flow to the west branch of the Brandywine River, but instead it turns in a south direction and cuts its own valley across the South Hills to the south of the Chester Valley, even though the Chester Valley floor continues without any significant interruption between Valley Creek West and the west branch of the Brandywine Creek. So this kind of makes sense if we had large volumes of water flowing in a southwest direction here, which were being captured by the headward erosion of first this valley and then this valley at approximately the same time. And these valleys were diverting the water, which had been going to further to the west in a south direction to Brandywine Creek. And then and the same process would have continued westward. And let's look at and so as the east branch of Brandywine Creek Valley was eroded across the region, it would have captured the southwest oriented water and diverted it south. Then this Valley Creek East Valley would have captured the water and diverted it south. But there wasn't a large time gap between these valleys, and also there wouldn't have been a large time gap between the erosion of the west branch of Brandywine Creek Valley, which is just west of here. Now, so again, what ended the flow in that end of the Chester Valley was the headward erosion of a deep valley along what is now the Schuylkill River route. And this deep valley captured all of the flood water that had been flowing in a southwest direction across this region. And as the valley progressed up here, it beheaded the south-oriented water that was flowing into the Chester Valley. This caused a reversal on Valley Creek East and causing it to flow in a north direction. And so this is what created the drainage systems that we see today. Now, if we Look at the Chester Valley. This is looking at imagery. You can see most of the Chester Valley here, not all of it, but much of it. So it stands out today as a major physiographic feature. And if we go to the west end of the Chester Valley, this is where the water would have been going. It would have continued, the southwest oriented water would have been continuing to the Susquehanna River, but the headward erosion of the Bowery Creek and also the other Susquehanna River tributaries that we see at Christiana, these valleys would have first captured the water. But the fact that there are no deep, high drainage divides between the various south-oriented valleys, drainage route valleys, indicates that probably these valleys were being eroded headward almost simultaneously across the large floodwaters. And here, this is Parksburg, and again, we can see the Delaware River, Susquehanna River drainage divide here, and this is the westernmost tributary flowing to Brandywine Creek. And so we're not, and again, the drainage divides are not high enough to suggest that there was large time gaps between the time that these south-oriented valleys were cut. Now, to make some concluding comments, I want to emphasize that the lack of high drainage divides between the 7 south-oriented drainage routes that now cross the southwest northeast oriented Chester Valley floor suggests that the Chester Valley was not lowered by karst processes or some other process that occurred after the drainage route valleys had been eroded, but was instead eroded by almost at the same time that a massive southwest-oriented floodwaters must have been eroding, causing the headward erosion of a whole sequence of south-oriented valleys into the region, with the south-oriented valleys probably being eroded headward in a sequence that was progressed from the southwest to the northeast. And so that the headward erosion of each south-oriented drainage route would have valley would have captured the floodwaters and ended flow to the regions further to the southwest. And we can test this hypothesis by looking for evidence both to the north and the south of the Chester Valley that the south-oriented drainage routes had eroded headward across massive southwest-oriented floods, although that's going to be a different presentation to consider.